Hello, this is Group 7. Our project is the BraiNet, which is using the brain signal for user registrations and user login. So our system has the one Android app and the two servers as a remote server and the fax servers. The remote server is hosting outside the ASU network, while the fax server is hosting inside the ASU network. So on the screen you can see 4 Windows and the 1 Android emulators, which showing our Android app. So for the 4 Windows, the upper 2 windows are for the fax servers, while the lower 2 windows are for the remote servers. So you can see the CPU utilizations on these windows, showing the server status. Okay, so before we start, I'm gonna first try to show the model server is not been created. Sorry, the model file is not being created yet. Okay, now I'm gonna demonstrate the remote server registrations. Okay, once we click registrations, there you will have a lot of different users that you can select for the registrations. Since our remote server is hosting outside the ASU network, so the network speed is much slower than the fax server. In here, we're gonna only select 2 users for registrations. Okay, now I'm gonna click the upload and trend. Once we click upload and trend, this Android app will first uploading all the brain signal from the user 1 and user 2. And from here in this windows, you can also see our remote server zip, the network, the bandwidth start increasing from like 100 kilobyte to close to 1 megabyte, which means the remote server is currently receiving a lot of data from the Android app. Once the transfer is finished, the machine learning algorithm will be called and the machine training will start. Okay, so the machine learning training is already started. So you can see the CPU utilization increased from like 10% to 30%. That is because it only uses 1 CPU core, and there's a 4 CPU core in our remote servers. And we are here gonna to wait. Okay, now the training is finished. It shows that it spent 55 seconds on the training, which including both file transfer and the training process. Okay, now let's go back and using the remote server to log in. Okay, and I'm gonna select the 5 users for login test, and click upload and test. So you will upload the 5 brain signal from the 5 different users and testing their eligible. Now the testing is finished. It spent around 10 seconds, and the system accuracy showing something like 80%. And the detailed status was showing besides each user's name. In here, the user 1 and the user 2 are succeed login, which means the system allows them to log in, and this is also expected behavior. While the user 3 and the user 4 are denied by system. Since they are not registered in the system, so they are denied naturally. While the user 5 is failed denied, meaning that the system allowed the user 5 to log in while it never get registered in the system before. So this is the false positive situation here, which is also the model error. Then I'm gonna demonstrate the fax server registrations and the login. Oh, before that, let me show you the model files we created in the remote server. Now you can see the model file is a model.dat, which is created, and it doesn't exist before we training. Okay, let's go back to the fax server demonstrations. Now I'm gonna register 5 users in the fax server. That is because our fax server is hosted inside the ASU network and has much faster network transfer speed. Okay, now let's click the upload and trend. As you can see, the file transfer is much faster than the remote server. And once you finished, please observe the CPU utilization in the fax server. You can see the Python 3 program now has 100% CPU utilization because of the machine learning training. Okay, now the training is finished. It only spent 50 seconds to train the 5 users. Okay, let's go back and use the Fox server for login. Now let's select the 8 users in here and start testing these 8 users. Now, as you can see here, it only spends 3 seconds. And while the user 1 to user 5 are succeeding logging the system, which is match the expected behavior, the system, the user 6 and the user 8 are successful rejected by the users, while the user 7 is failed rejected by the user, which the failed rejected by the server, which means the server allows the user 7 to log in. So this is also a model error in our SVM training system. The last feature I'm gonna show you is the adaptive feature. So the adaptive selection is selected between the remote server and the Fox server automatically by the system or by the Android app. So what we're doing here is that we will first try to send the one small files into both remote server and the Fox server, and observing the transfer speed among these 2 servers, and choose the whichever server which has the last transfer time. Okay, let's click register. Okay, I think there's some problem here. Let's go back and let's click again. Okay, now it works as expected. Now the adaptive test result showing that the remote server will spend the 3 seconds to finish the transferring the small files, while the Fox server also only spend 2.56. So here the Fox server will be chosen. And you also can see in the register in here the action bar saying that the Fox server is chosen in here. So and then we can resume the normal activity. Okay, so let's choose only 1, 2, 3, and 6 user for login. For registrations. So it's only 47 get upload into the Fox servers. And so once finished, we remain use the adaptive for login. And then we choose the 1, 2, 3, 4. Okay, so the training just finished. So we choose the user 1 to user 6 and upload and test. Now the user 1, 2, 3 and the user 6 are supposed to be allowed to log into the system, which are correct by our machine learning algorithms, while the user 4 and the user 5 should be denied by the system. The user 4 is successfully rejected by the server, while the user 5 is not. So again, it's a model error here. Okay, so now this is our demonstrations of our project. So currently our project still has one feature lag, that is the power consumptions measurement. We will finish in the next week, which is before the deadlines. Thank you.